Hello and welcome back to another session of Learning Rust with Gadoxide. Hi, Sydney.
Hello, Sebastian.
Good to have you on the show so regularly.
Once again.
And yeah, this is our yesterday's state where we created our own option just to understand a bit more how options think, what that API is, that many functions that you can call on options like map are actually consuming the option itself. Because if you don't consume it, then yeah, certain things you just can't do. And we also learned that options, usually when you take them in functions, that you want to own them. But what's inside can be borrowed, doesn't have to be owned. And that's really what option wants. Don't do this, but do this. And that's it. I think it's worth using this once more in an API that is a bit, or with an example that is a bit more practical, like really practical. Because here we have main, which is a program. And even though it's not so very obvious here in the IDE that hides all these things from you quite effectively, if I do run options and results, I run my binary here. And it's actually, oh yeah, right. Let's do this. I run my binary, which is here. And that's really all that happens, but I could provide it with arguments. Oh, interesting. So if I wanted to run this directly, I can see here, I can. And of course, you can also provide arguments to that and then do something useful depending on the arguments that you get provided. And doing that correctly, of course, is a super time-consuming thing. I mean, there can be this. I mean, it's argument parsing. And that, and this, and then maybe another that at the back. Like, ooh, like implementing an argument parser yourself, probably not what you want. But it's useful sometimes if you want to go quick and dirty and, you know, just want to have one or two arguments that you need. Why pull in a full-blown argument parser, which is command line argument parser, which is clap command line argument parser. So that's the crate to use. That's the default. That's what everybody uses. It's great. Just use it. It's fine. It does have some shortcomings. It's bloating your binary a bit by 300 kilobytes and increases build times and link times because it's quite big itself, because it has all the features that you ever want. But usually it's worth it. If it's tools you like that you're doing, then you use clap. It's just like this. But now we just do manual argument parsing. And that's done with std env args. All right. Let's see what this does. Interesting. I don't know much more now. It returns an arg struct. And fortunately, there's an example here that tells us that you can iterate that struct, which is also interesting. A struct you can iterate just natively, right? Like, how does that work? It's a bit like magic, but let's do that. Let's do magic for arg and args. Let's print the arg. Like that. And there's nothing to see here except for the first argument is always our executable. And everything else is the arguments themselves. Okay. Not too bad. In a way, I think I'm now sliding into something I didn't even want to do. It's about iteration, because now, inarguably, you have to deal with this a little. But let's do that. Let's just go with the flow and see if we can get some options back and can finally get to results. I had some idea in my mind, but I think it's falling apart right now. That happens. We'll figure it out as we go. Okay, so first thing, how would I skip the first argument?
Okay, so you mentioned iterators. So is that something you would do, like using the iterator? Can you just say skip one or something like that? I don't know.
Somebody has read the manual, huh? Or it's so intuitive.
I did remember something.
Oh, it's so intuitive that it actually works. Let's use cargo run instead. Cargo run, and we say hello world. Oh yeah, now I have to specify a package because there's a workspace with multiple binaries. So the package is options and results. And there we go. It does work. It just skips one. Fair enough. Okay. And now I want to get, and now we get back to option, fortunately. I want to get exactly 2 arguments. And not more, not less. Should be fine. But now I'm in this loop here, so I can probably count things and kind of keep remembering these things that I get, maybe. Put them on a vector, maybe. Like, you tell me, like, I just, like...
Yeah, I'm just thinking, I mean, I know usually, for example, in Python, right, there's this enumerate thing where you can also count the index next to the value.
Mm-hmm.
Maybe that's useful, and then you can just check for the length, basically. Or just stop after 2.
Okay.
All right.
Same thing here, so we can enumerate. So if arg I is 1, this is 0 based. Alternatively, we can put the enumerate here. Now we have 1 based iteration as we skip 1, but it's part of the enumeration because we enumerate before the skip. So now we get what we will skip later as well, I think. So, but that's the thing, you know, now I have to I basically have to remember how many things I've seen because I want to also say I need 2 arguments if I didn't get them, if you get too many. Also bark, only 2 is okay. So now it's a bit like this will be complicated, I think. So of course the idiomatic way would be more something like this. Let args be this, or maybe at most 2 args. Because I now say I want to take 2. And now this iterator will stop after having taken 2 items. But it also stops if there's not enough items. And I can just collect this into a vector. Ah. Why does it not?
Okay, so take is the same then as we used it the last time, where it just grabs the thing and pulls it out, essentially?
Right. I didn't even realize that take is the same word that we use in the option. But yes, it has the same effect. I take, well, actually not really. I must say not really. Because we don't really take ownership of anything. This is unrelated to ownership, but we take 2 items out of the iterator and stop iteration after we have 2. But it's still part of an iteration, so it doesn't build any new data structure or something like that. It's really just taking 2. And now, of course, I could check for the amount of items that I have here and say if at most 2 args isn't actually 2 args, then somehow abort the program. So for now, I don't know much. I mean, this I could do, huh? I could panic explicitly, this aborts the program. It's like throwing an exception, but not having exceptions. It's really abort with a message, nothing else. We can do that. Need 2 args. Let's see how that works, or if it works. So it's happy now. But now that I add a third one, I should probably move this window up a little. Now you see, oh, it's not actually barking at me because I only ever take 2. If I have not enough, it will tell me that I don't have enough.
Okay, I see.
But I only take 2 off the list here. So that's not even something I can do. I have to see, I have to at least get 1 more than I need to know it's too many, right? And now this gets even more interesting because I have to kind of take 2 manually maybe. And in a way that's a contrived example, but also not that much. Sometimes you just need 2 things. Give me this path, give me that path, and I do something. So not too far away from reality. I think I've done that. And of course, what you can do is remove this take 2 so that you get possibly more. And then just manually increment the iterator and say, okay, I take 1 arc, I take another arc, and if the next one isn't there, then cool, then it's a problem. And if you want to do this a bit more Rustationy, or sorry, a bit more idiomatic, you could of course match on it and say, I want 2 arguments. So I just put them into a tuple, take both, and match on what I have here. So if I have some arc1 and some arc2, world is happy. And anything else really isn't great. But maybe I want nice error output, so I really want to say what's wrong. So I could say, okay, we have 1 argument, but not a second one. And say need 1 more. Or I have nothing. Need 2 more. Something like that. And you see how match can be used to be super powerful, because you can just match on structures of any kind or build structures that you need on the fly. Like this is a real tuple that has 2 things in it, but you destructure it right away and look at what could be in there possibly. And it's not actually happy right now because 1 pattern is not covered. So none as first argument, but then the iterator produces something. This is not possible, right? This iterator cannot work like this. But match does not care. It must be exhaustive. All permutations, please. So we can definitely say that this is unreachable. Iterators don't work that way. Yeah. But one could also say that's a bit dangerous because now we kind of, this is catch-all, right? That's the default case. So we might as well say, actually, what we are interested in is this. And then we, as we change the top, we will not just magically run into this code and think everything is fine. So that's probably better to do like this.
And unreachable is just like panic, but with a different name or with an explicit name.
Yes. I mean, the semantic is now different, but the program will abort. You're right. But you can search for unreachable and I mean, see immediately that this should not be possible according to the logic of the program, which also usually means sometimes I write this just to say this must be a bug, but it's implied if you hit unreachable code. I think there's an XKCD comic about just that. Not Rust specific, but definitely you should not see this. And then some sort of passage prose about why this is. All right. But I also don't have the case that if there are too many arguments here. So now this should be fine. Happy. Need one more. Need two more. But it's still happy now, right? And maybe that's also not so nice. So yeah, we could of course just put that here, huh? Put another case here and just have a third one and expect that to definitely be none, and then update the rest accordingly. And then you probably need a catch all for this, because then you have many more permutations that we definitely don't want to write out just now. Or alternatively, maybe even do that here. If args next is some, let me panic as well. Too many args. Otherwise you print happy. And now we should be able to catch that case too. And you already see manual command line parsing, except for the most simple cases, is kind of cumbersome. And there's probably many ways to write this or to make this better. I would probably just collect it into a vector and then say, use the length of the vector to determine what to say there. Or maybe even not say anything, because maybe the tool is not that important and it's really just an expert tool, up to you. Or just use some argument parser crate that matches your requirements, because there are quite some.
Doesn't the iterator have a length by itself? Like, can't you just tell the length of the iterator?
Let's try. Actually, let's try. Because the amount of arguments is predetermined, right? Like it's visible. Even though this is an iterator. A great idea. Let's try. Let's just do it like this. Oh! Should be 1 at least, right? Oh no, wait. That's wrong. Because we skipped 1 and here we don't actually have more. Yeah! It's an exact size iterator. It's a thing, it's a trait, exact size iterator. So some implement that and then you can get the exact number. You can also ask for a size hint. This gives you the lower and upper bound of an iterator. If known. So how does this look like here? See, so this is a specific exact size iterators always give you 1 bound because it knows the size, and there's just 1. And that's interesting. Yeah, so you could work with that and then just extract what you want to extract. Maybe it's then more like this. Not equals 2. Panic, need exactly 2 args. And then you could collect it into arguments, which is a vector of things, or you just extract it yourself by matching on it. If you have options there, every time you call next, it's a bit cumbersome. This is why I probably would be somebody who then collects them and works with the vector. Collection allocates, right? So that's definitely more expensive than just iterating the arguments. But it doesn't matter. It really does not. So now, as always, reassign, rebind. So here args is an iterator, and here it's a vector. And we know it's exactly 2 items, so we can just work with that and do interesting things with this. And that should also just work fine. So this one works, this one does not. Yeah, great idea. I think there was a time very, very early, 5 years ago or 6 years ago, when args was not an exact size iterator. And then you also could not do something like reverse. You can reverse the order of the items that you get. Take it from the back to the front, iterate from the back to the front like this. But that only works if you know what you have, and not all iterators know that. So those who are not exact size they usually can't iterate a stream of things from the back because it's just unknown. It's not there yet. So,
yes. So they step through every element essentially until they reach some sort of end.
yes, and that's the default. That's the way to do it. So having some sort of index that you count, and then you do args I for the index. That's something you don't ever do in Rust, or in cases that are really specific to math or image processing. If you have matrices, then I guess you access these all the time because you have to. And you could think that in theory that's expensive because each access costs you a bounds check, because we know Rust will panic if you're out of bounds, and it will never not do that bounds check for that reason. It's important. It has to happen. And you might think, I don't want to use Rust for math or for image processing or anything that is computationally expensive. But yeah, the optimizer is incredibly powerful. And what you usually do in these cases is you basically make an implicit assertion that says, look, I give you a hint here. I say I have 2 args. I have a slice of 2 args, and it's going to be created like this. So here you see the syntax here, right? So I now don't get an individual item, but I get all items from 0 to not including 2. So I get index 0 and 1 now. And that's a slice here into my vector. So it's a borrowed section of the vector that is consecutive in memory as well. And now the optimizer sees a bunch of numbers. And this access here will be bounds checked, but only here. And from here on out, the optimizer knows that even though there's code now that makes a bounds check, because it's just part of the implementation, it knows that it cannot possibly be bigger than 2 because that was already checked. And now this access here is free. It's now just here. Dereference that portion of the memory and give me the result and do stuff with it. And this is how things get fast. So when you know your size, but we have a matrix here of 16 things, right? 4x4 matrix, very typical. You do that, and then you operate on that slice instead of operating on a vector that could potentially hold many matrices laid out in some order behind each other. And then you would pay, probably. I think you do, because then the optimizer doesn't really know what the limits are depending on what you're doing there and how you use your numbering there. So
that's something you have to explicitly look out for, like knowing this will help you probably in optimizing your code.
Yeah, I don't even say that you should just do this by default, especially not for this case, right? Never. It's just something that if you do computationally expensive things, this can matter, but also the optimizer might catch it. Nonetheless, you don't have to. I mean, this is a surefire way to trigger that, the removal of bounds checks. But also I'm saying never assume that what you're doing, just because it looks so high level, like this stuff, is expensive, because it's not. What comes out at the end is like a handwritten loop that you would do in C that, you know, does just what's needed in most cases, and not all of them, right? But most of them, or many, let's say, I don't know. And it's getting more and more and more because optimizers are getting better and better, of course. So don't ever optimize something away or try to optimize because it doesn't work. Just write idiomatic Rust and it's going to be fine. Until you have performance measurements, and then you can optimize and maybe you get some percentages there. But yeah, allocations are usually a good way of doing this. But I guess we are not really doing options here. Sorry for that. This is where clearly my bad. However, let's get this one segue right at least, because this panic here is certainly not a way to write a nice program, because that's not so nice. Like, this doesn't look good. It's like your program crashed. And it did. It crashed gracefully. So yeah. And let's see if, let's just try. Let's see if we can return an option here instead or something. Let's see if that works. Because the option is the only thing we know. Like bool for true or false, return false out of main, and that means error, but it's not crashing. So if this would be a print line and then return false, then here return true. Let's see. But it doesn't work. Can only return types that implement termination. Termination. That sounds very final. And it is. It's the end of the program. And that again is a trait. And that trait is implemented for certain types like unit, which allows it to be used as a return value. So unit is implicit as we know, and that works. But I still can't return anything here. Let's see if option works. Doesn't look like it. Yeah. But it's barking at something else now. It wants an option unit. So this is none. And this is sum. Like this. Also, we don't use return. That's unidiomatic. But again, same problem. So now, if we know that an option is either sum or none, I think there is a logical progression to this. Like what if I want to have a value that indicates what kind of thing is wrong instead of just none, which says nothing there. And then, yeah, you know it, you say it.
Yeah, it's basically like I would say the traditional error, like an error message that you can actually go ahead and handle. And that's probably then the second type that would hold, right? So one value that's okay and one value that's an error.
Yes, that's exactly like it. And that's our result. On the right side here, you see that these are variants of our result type. Yeah, maybe when we do the remake of the show here in a couple of decades with gray hair and everything, then we can find a better segue from option to result. Note to self. However, yay. Let's try that. We have a result here. Now we have two things that can happen. So not just the type for the OK value. Daddy is busy. Geh schlafen. Yeah, okay. So, what about this? Oh, look at that. That actually works. So now it's happy, and now it's not happy, and we see the error itself. So in a way, I don't have to print that anymore. I could now, as you said, have a value for my error. Let's see if that works. Does it like that? Apparently not. Ah, of course. Let's change the type. Oh. And it does compile. And look at that. Error, need exactly 2 args.
So it doesn't need to be an error type. That's just the name of the variant, basically. The ERR. That's just what it's called, but it doesn't expect a certain type. You can put in whatever you want.
Mm-hmm. It's the upgraded option, so to say. Option with superpowers. Cannot only have some, but also have none, which is now called error. So this is indeed specific to a result that is either positive, worked, it's okay, or it's an error. And that's how it's supposed to be used as well. So don't use it as, oh, I can have one of 2 values, and it's maybe one or the other, like maybe. there's a crate that is called maybe that implements maybe, which is either that or that, which I think Haskell might use for results. But this one is specific to if you want to return something more specific in the error case. And apparently that can be just strings like this, which, you know, the automatic printing here is not super awesome, huh? So I could imagine that unquoted, that the quoting here is not necessary, and it doesn't look great, but it works. It's kind of the first incarnation of this, and in fact that's a debug print here. So if you have a complex type in there, it will not get better. It will not. It will look a bit codified then if you see type names show up there, for example. I don't know. Let's see if you can trigger this. Let's try to convert the static string into an own string and see how that looks like. I think I can just run this here. Okay, still looks the same way because that's just how strings are represented in debug. It's not making obvious where that string is stored, makes no difference to it. But the more complex your type, the more you would see kind of a debug-like printing that will probably not be the best experience for the user. But for little dev tools, you know, you can probably just get away with returning a few strings instead of panicking, which is definitely better. And no printing here. Yes. And that's like the most top level result you will ever see in a Rust program, I guess, as the return value of your program. Which, by the way, also affects the return code. So this is a non-zero error code now. So has to be an error on the shell, in the shell as well. And this one here is fine. So that's kind of for free there when you do that. And results. Let's have a function. Let's see. I mean, now we have booleans and we have options, and now we have the last step here in that evolution, which is result. And we already know that options have a lot of methods associated with it that allow us to chain operations. And these compose nicely when you work with options. And now let's see how that works with results or results with options and what we can do there real quick, just so that we get a glimpse. Okay. So what about a function that adds 1 safely? So we have a value that is a U8 for simplicity. And now, if that addition worked, if we could add 1 safely. Ja, geh schlafen. Ja, ist okay, geh schlafen. Yeah, okay, I have to hurry that up. Either it's that or it's some sort of error. And maybe even it specifies what the error would be in a message that we can then consume here. So that this can just exit the program as we know it. So, did we ever talk about the static here, by the way?
Yeah, we did. That's basically these values that are embedded in the binary, right? That it's basically it can know that it has a static lifetime because it's in the code.
Yes, it lives as long as the program, but what static really means is it's owned. There's nothing borrowed here. It's, in this case, I mean, the static lifetime, I think that's something that took me a long time to understand. Everything in Rust has a lifetime. And owned things, they also have a static lifetime associated with it. because usually when you use own things, you move them around. So they're static as long as you keep a handle to them. And that's giving them, as far as Rust is concerned, a static lifetime. So whenever you have a static bound on something that says, hey, I need something that lives forever, essentially, then you can always give it something owned, because it lives as long as that thing that wants it lives as well, by definition.
Okay.
Right? So however, if you say you want something that is static, you can only live as long as you yourself are active. And if you own that thing, then of course it's yours. It will stay yours as long as you are there. Fine. So static, good. Owned, good. And that's really something that took me a long time to understand, because lifetimes are not visible with owned things at all. But they're there. Or they're counted as such, let's say. Maybe I'm explaining this wrongly, but that's effectively what happens. But if you borrow something that is owned, then it has a lifetime that is specific to how long that owned thing lives, and it's never static, because it can't be, because that owned thing goes out of scope at some point, and that's not static ever. Interesting. All right, so add one safely. And let's also do that here. Maybe remove that or ignore it, and then have add one safely to, and this. Let's add many new things just because I don't know better. Okay. So I would expect let's just do it unsafely. Maybe like this, v plus 1. Let's print that. And it prints 3, that's great, works. And then let's go with 255, which happens to be the limit of what this can represent. Oops, panic, and attempt to add with overflow. So that's a panic. That's not what I expected. I wanted a safe version of it that gracefully exits my program. And yeah, those who say, I want to do a lot of computation, and if Rust does overflow checks for everything implicitly, then this costs you, right? It's not for free. How come? So here's the thing. In debug mode, integer overflows are checked, or underflows for that matter. So you have additional safety and your program can crash, but that's what you want, just to see, hey, there's a bug. But only in the debug build, which is kind of slow to execute anyway, so probably math won't run there, but you can configure that anyway. You can also configure a release build with overflow checks if you want to, which is probably good to know, because that can help you catch math-related bugs. But what you can also do is use methods on an integer that do safe versions of this. So now you say, instead of panicking if it's enabled at compile time, let's do this. And if it worked, you get the results. If it doesn't work, if it didn't work, you get an option. But now we got the problem that we have either that we have an option here, but that doesn't qualify. That does not qualify as we'll talk later. That does not qualify as result. So how do I upgrade this? How do I enrich it with possibly an error? Unfortunately, that's a common thing.
Yeah, in this case, it seems easy because you have the sum value, right? And then you just add the error value. So it should be kind of easy to kind of unwrap it and then construct your own results.
Yeah, unwrap panics again. But if you match on it, because you have to get it out of the option, and unwrapping it gets it out, but also it panics. So the only way really is to say, if there is something in it, then we repack this essentially, right? We say make a sum into an okay and make a none into an error that is overflow or something. So that should work. And it does. So that's cool. But also, again, it's a very wordy. And if something like this that seems common is wordy, then of course there's better ways. And I think this is like the first 30 minutes that were kind of a bit lost in different kind of things that are all very interesting. But, you know, this is really what I wanted to show here. This transition from an option to a result. And there is something like that, which is okay or else. In our case, okay or will be fine. Because all we have to do here is give the error string. That is overflow. And we are fine. And if you look at the code, you'll see that it's exactly what we just did. And that's that. And easy, yeah. And looks nice too. And this kind of chaining, it really gets you addicted. I mean, I have to see a therapist or counselor at some point just to see if I can get off it, because I write a whole program that's just one long chain. It's it's wrong, but feels so good. So what if it's the other way around now? So if we have something that works, we want to invert the meaning. If there is nothing in there, we want to have an error. So kind of literally the other way around. Is there something?
Yeah, I see.
So
I mean, I'm guessing there's a method for it as well, right? Because in the match statement, you just have to switch the output expressions.
Yeah, that's true. There you can do it. I think there isn't actually a method for that. There are cases when you feel like you want to do something else. I've been there at Git Oxide. I think we've done that together. I don't think I can reproduce this here because the types will not match. But if you need something else than okay or else, then I think from my experience, you already have it. You already have a function that does it. You just have to think the right way, so to say. So you don't usually have to do these matches yourself. Unless ownership is involved, then you might have to do it just to make ownership tracking clear and avoid closures. Because when closures come into play, then ownership tracking or ownership changes, and you start to have to borrow things here inside of the closure. And that affects, of course, other parts of your program. And then it might be necessary to match if you get into borrow check issues. But only then. So until that happens, I'd say try to use these these functions or methods. And definitely be aware of them. Just look at the whole documentation and have seen them once at least, so that maybe you can remember to have seen something like that when it's time. Yes, but that was what was already pretty neatly looking here. Is okay or overflow, and that's how most of the Rust code can actually look. So if you want to, you can technically say std env args lang is empty. Sorry, lang or args. Can I say arg is empty? Cool, I can, because exact size iterator has is empty. And if it's empty, then I can. Oh, that's interesting. Now I think we get into the case that I wanted. So now we can have an option with a message in here. Need 2 args, for example. And now what do we have here? We have an option with something inside, a sum. But we want to invert that. We want to turn it into an error. Yeah, I think this session is nearly over. So let's turn it into an error by mapping it. And then we should be able to just exit early like this. And what's this? Oh, it's an unstable feature on exact size iterator. This can still happen with that early in Rust. Okay, so if you could do that, you could start chaining things like this and still nicely wrap stuff. The question mark operator is also not working here because we don't actually have an error yet, but with the transposition option, with an option result, we can transpose it into result option. And we don't care about what's in the option. And this could be your chain to quickly go from Boolean to option with an internal result to result option, which you can then question mark on. Question mark is a try. If something is in there, then do that, take it, take the OK value, otherwise return with the error value. Most common thing to do. And I think we also just silently introduced this without talking much about that, but that's what it does. Exit or get me the value, or return or get me the value. Yeah. And whenever you have a Boolean, I just say, do that. If this is supposed to be the error case, cool, do it, map it, transpose it, and you don't ever have to match on it. And even though in the end you might end up with more lines like this, because will always be this one line per chain item syntax, somehow I like the flow of it, but maybe one day it will be forbidden by Clippy. Do we have Clippy here? We do. But until it's not forbidden, I think we are good. Oh yeah, this is the other project that I probably should deal with at some point. Yeah, so I think that's all we have for results and options, and that probably concludes this series. And next time we will probably talk more about error handling, which the results are an integral part of. All right. Thanks a lot for watching, everybody, and see you next time.
Thank you very much. Bye-bye.
Bye-bye.